this week I set up my character to move over terrain. He moves in any direction, he goes up and down over the terrain as it goes, and he even has a little factor where he moves slower uphill, faster downhill, and the steeper the hill is, the slower he moves when he's going back up. How I set up this code is similar to the create your own pathfinding AI. I put a card to the video just now. So this starts with about 9 public variables. They're all important. You got a public game object, rally point. Rally point is just a empty game object. All it really does is hold a position of where the soldier is going to. And then terrain is also one of the public variables. So the script is down here attached to the soldier, and you just drag and drop your rally point in your terrain in where the public variables are. We got 2 vector 3s, one holds position, and then the other is the direction to the rally point. And we've got a vector 2 slope position. I'll explain that later. You got a float distance to rally point, a float for speed, a float for your previous Y, which is how he knows if he's going up or downhill, and a bool path clear, which basically tells you not to run this code if the character's not supposed to move. So at the start of the game, you want to make sure that your vector 3 position is set to whatever the position is of the soldier. Then in update, the first thing we check for is if there's input on the screen. And to make sure we don't get this input run 100 times, it only runs if the phase is began. And it goes to this function, reassign rally point. So what this does is it sends out a raycast named hit, and we made a variable touch, which just gets the input, and then a vector 3 touch position to store that input. Now we create array using camera.main.screen to world point. So basically it's a line going straight from the camera to wherever you touched. Now this if statement right here checks to make sure you're not touching a button. Event system.current selected game object. And if you're going to use that, which is important, make sure you add in Unity engine.event system. Then when you go down here, this checks if physics.raycast, if the ray hit anything going to any amount of distance, change path clear to true, which means it starts this loop, and make a new vector 3, which is the exact points in the X, Y, and Z coordinate that the rally point hit, and then take the rally point transform position and make it equal to this new position. So once that's going, then what we're going to do is run a thing that finds out the way that the soldier is traveling. But the first thing we do is actually calculate slope, because we want to know whether he's walking up or downhill. And so we've got the variable slope position equals new vector 2, and it's position.x, that's the variable that saved the position from wherever the soldier last was, and then minus terrain.transform position.x. If you look over here, the terrain, remember we had to move it a little so that it would be in the center of the screen. And what you're going to calculate with slope, it's a really weird way that they do it, you have to make sure that your terrain positions are based off the terrain position, not the world point position. So you do the same thing for the Z component. Then what we do is we normalize the variables for slope position. Basically, we're making them between 0 and 1. And all we do is take whatever positions we already had and then divide slope position x by terrain.terrainData.size x. And it's almost the same here. Just remember that you go slope position.y over terrain data size z. And the reason for that is the terrain data is actually has a width, length, and height. So this is the z, and if you make it y, you're going to have a number that's totally off from what you're trying to do. And the next thing we do is calculate the slope of the terrain. So terrain.terrainData.getSteepness, get the slope position x and y. And then after we calculate that out, we have this previous y. Basically, this slope will always be a positive value. So even if you're going downhill, it'll say like 25 degrees. And so for the calculations we run later, we need to not run that if he's going downhill, because going downhill doesn't slow you down. So the previous y is calculated after you calculate your new position. And so it's already there, and if it's greater than or equal to your current y position, then slope equals 0. Then you go ahead and save whatever your new position is to your previous one. Or actually, I guess this would be 2 positions backwards if you want to think of it that way. Let's move on. So you calculate the direction to the rally point, which is rally point dot transform dot position minus transform positions. So it just subtracts the 2 points and gets a vector. Then the distance to the rally point is vector3.distance, which automatically calculates the distance as long as you put those 2 points in there. Then I have this local variable called float ratio x and float ratio z. I used them in the previous script that I referenced. Basically, we take the direction to rally point, its x and its z components, because we want to make sure those are lined up. Say if he's going diagonally, we need separate components for each. And we divide them by the distance to rally point, because that gives us a ratio of how far it's going in each of those directions. But I add 1 to the end of it. And the reason for that is this ratio right here tends to 0 once it gets to its destination. And if its distance is also 0, then it just shakes back and forth forever. But if it's 0 over 1, then the character just immediately stops. And that's why I have a +1 here. Now, the next thing is calculating the new position for your game object. So position.x is adding our plus equals the ratio, which is always going to be between 0 and 1, times the speed, which right now is 2, and then math f cosine of the slope. And so cosine at 0 is 1, which means that if there's no slope, then there's no change in speed. As the slope goes up, then the cosine gets closer and closer to 0. So if you actually hit a 90-degree slope, your character will just stop and won't be able to move anymore. And then we have math f degrees to radians. We calculated the slope in degrees, but the cosine calculations in Unity need to be in radians. And then we multiply that by delta time. And it's the exact same thing for position z. And then we create a vector 3 temporary position. And the only thing it's used for is to calculate the position.y, which is terrain.activeTerrain sample height, which gets the exact point in world space of the position, which is a vector 3. So I just left the y blank because y doesn't even matter. As long as you got your x and your z, you're good. And we just finished calculating that. And then once we get that height position, then we just put the entire transform dot position equal to position. So we make the soldier's position equal to his new position. And that repeats every single frame. Now when it comes to going around trees, so far right now, he just goes straight through the trees and out the other side. Part of the reason he's going straight through the trees is look how skinny they are in comparison to his body. Now having the soldier hide behind trees and rocks is going to be a major element of strategy. So I'm going to have to fix this in subsequent videos. I could enlarge the trees to the point that they would be big enough for him to hide behind. The only trouble that I'm having with that is if they're big enough for him to hide behind and we look at them from the top-down view, we won't be able to see the soldier. Which is why the first version of my game I was just going to make pine tree cylinders. Because normally when you're standing next to them, they got some stuff above, but really I've been in pine forests where all you see is just like the stumps sticking up everywhere as obstacles. We're going to have to fix that in a later video. Thank you for watching another episode of SS Street Fighter. Leave a like, leave a comment, and click subscribe to join the Street Fighter army. I'd also like to send a thank you to my Patreon supporter, Charles.